Hello, Matt. So I saw your video with the prisoner riddle. They had to pick the cards out of the slots. They could only take 5 out of the 10, and they had to, get their own number, or they were all going to die. I thought it was a really great riddle, and you wanted to know if there was a way to work out how many for any number of prisoners. So I've come up with the formula. I've worked it out in my head over the last 2 hours, and I've written it down for you here. So this was my notes. This was my notes. Of me working it out for 4 and for 2, and I didn't go higher than that because it gets ridiculous because it's factorials. But here's the formula right here, nice and simple. So let me show it to you. For any number, come on, camera, focus. Camera doesn't want to focus. For any number A, which is the number of prisoners, I know it looks like happiness at first. It's not happiness. B is the cards divided by the number of prisoners, so basically one half of the total number, because you're using two. You're using two. They're allowed to pick 5 out of 10 cards, so that's 1/2. So yeah, and then C is every whole number from 0 leading up to, but not including A times B. So in this case, 10 times 5 over 10 is 2. So up to include, 10 times 5 over 10 is 5. So this would be up to including, but not including 5. So I've done this. Come on, camera. Focus with me here. Okay, so here's your formula. A factorial minus C minus that as many times as possible, all over A factorial. So let me show you what that looks like. So for 2, there's only 2 possibilities because we know 2 factorial is 2. And you've got 1 leads to 2, 2 leads to 1, or just 1 and 2. And there's only one solution for that where they could win. It's this one here. And working that out through this, 2 factorial minus 2 factorial over 2 minus 0. And I didn't go to 2 minus 1 because 2 minus 1 is 1. And 2 over 2 is 1. So up all numbers 0 up to not including 1. So only 0 is possible for C in that formula. So just that. And so then we get 2 minus 2 over 2, which is 1, all over 2, because 2 factorial is 2. So 1 over 2 is the probability of victory with 2 prisoners. Now, take 4 prisoners. Assuming the same number, they're only allowed to take half of the cards. I've worked this out. And so for 4, half of 4 is 2, so up to and not including 2 is just 0 and 1. So this is 4 factorial minus 4 factorial over 4 minus 4 factorial over 3, all over 4 factorial. So I've worked that all over here. So it's 24 minus 24 over 4, which is 6, minus 24 over 3, which is 8, for a total of 10 out of 24 chances, or 5/12. I haven't done that in decimals yet, but 5/12 is the chances of them winning when it's 4. So it's getting a little bit closer to a third, because I'm pretty sure the limit is a third. Now for 10. You've done 10, so you know the numbers on this, but I've worked it out for you. So half of 10, with the way you did it, is 5. So up to, but not including 5, we have 0, 1, 2, 3, and 4. So we've got 10 factorial minus 10 factorial over 10, minus 10 factorial over 9, minus 10 factorial over 8, 10 factorial over 7, 10 factorial over 6. All over 10 factorial. And that comes out to the number you had, but I've done the maths for you here. So I'm not going to read it off. I'm just going to point to them on the screen. And that simplified out to, get this, the math worked out, it came out to 1,285,920 over 3,628,800, which was that number that you got on screen. So this formula works. This actually works. But I don't know how to graph this. I need you to help me graph this, Maddie. I'm sure there's a way. There's a notation that I'm just not aware of yet because I haven't learned the maths. That says to do this over and over and over again until you can't. But I don't know how to do that. So perhaps if someone could find a way to write this, maybe I've written it correctly and I just don't know. But I don't know how to do it. But this would be the graph. If you could define these values. So that's how you would have to do that, and it does work out. There you go, Daddy. There's your solution.